Hello everyone, hope you're doing well. Welcome to part 4 of this series of LibreOffice Calc tutorials. My name is Chinmaya and in this video I will demonstrate how to use Solver in LibreOffice Calc for solving optimization problems. In part 1 of this Calc series, we used goal-seek. While goal-seek is useful, the limitation is that goal-seek works with only one variable. Real-life problems are, however, complex and need to factor in a number of variables and constraints. Solver permits you to solve such multiple variable problems and find optimal solutions. To demonstrate the functionality of Solver in this video, I am using an example from an iconic book, Applied Mathematical Programming by Bradley, Hacks and Magnanti, professors at Harvard and MIT. Let's start by first understanding the problem story, and then we will work through this problem in Calc using Solver. So let us assume that we are a small company and we hire this glass injection molding machine to produce two kinds of glasses. One is a cocktail glass and the other is juice glass. Once these glasses are produced, they are packed in cases, and each case of cocktail glass occupies 20 cubic feet of space, and it brings in $4.5 of profit. Its profit contribution is $4.5 per case, whereas for juice glasses, each case of juice glass occupies 10 cubic feet of space and its contribution to profit is $5 per case. As far as cocktail glasses go, this machine can produce 100 cases of cocktail glasses in 5 hours, whereas for juice glasses, this machine can produce 100 cases of juice glasses in 6 hours. There are some limitations also. This machine is available only for 60 hours per week, and as we keep producing these cases, we store them in a warehouse, and the capacity of this warehouse is limited to 15,000 cubic feet per week. So all through the week we keep producing these cases and storing them inside this warehouse, and at the end of the week we ship them out and we can produce more cases for the next week. But for the ongoing week, these cases are stored inside this warehouse and the capacity of this warehouse is limited to 15,000 cubic feet per week. Now, how many cases of these cocktail glasses and juice glasses can we produce? As far as cocktail glasses go, there is no limit. We can produce as many cases of cocktail glasses as we want, but for juice glasses, we cannot produce more than 800 cases of juice glasses per week. So that is the limit for juice glasses, and this is because of an input from our marketing department. We cannot produce more than 800 cases per week of juice glasses. So the important question here is, how many cases of cocktail and juice glasses should we produce per week? That is what we are trying to find out, such that our profit is maximized. So for optimization problems, these are called as decision variables. How many cases of cocktail glasses and juice glasses should we be producing? These here are constraints. Machine is available only for 60 hours a week. The storage capacity is limited to 15,000 cubic feet per week, and we cannot produce more than 800 cases of juice glasses. So all these are constraints, and maximizing profit is our goal. So the entire objective of this exercise is that we want to find out what kind of production schedule should we have, how many cases of cocktail glasses and juice glasses should we produce, such that we are able to maximize our profit. So I've put up the original problem from the book, and you can pause the video and also read this problem. But the story that I have told in the previous slide is actually capturing this narrative. So in summary, what we know is as follows. The space occupied by every case of cocktail glass is 20 cubic feet, and the space occupied by every case of juice glass is 10 cubic feet. The time it takes to produce 100 cases of cocktail glasses is 5 hours, and the time it takes to produce 100 cases of juice glasses is 6 hours, and the contribution per case for cocktail glasses is $4.5, and the contribution to profit per case of juice glass is $5. This is what we know about the constraints. Maximum time that we can use the injection molding machine in 1 week, that is 60 hours. The maximum space that is available in warehouse is 15,000 cubic feet. So we cannot store more than 15,000 cubic feet per week in the warehouse. And the maximum number of cases for juice glasses is 800 per week. While we can produce as many cocktail glass cases as we want, the maximum number of cases of juice glasses per week will be 800. If you wish to follow along, you might pause for a few moments and consider taking a note of all these parameters on a piece of paper. So let's now head to Calc and work through this problem. So I've started a blank Calc sheet and I'm going to put in all the parameters that we had seen a few moments ago. So cocktail glasses and juice glasses. On this side, I'm going to start entering the givens or what we know from the problem. So space per case, and this is in cubic feet. I'm going to come here and enter 1 case of cocktail glasses occupies 20 cubic feet, and 1 case of juice glass occupies 10 cubic feet. Time for producing 1 case, and this will be in hours. You will recall from the previous slide that it takes 5 hours to produce 100 cases of cocktail glasses. Now, because this is about 1 case, so let us enter the time it takes to produce 1 case. As it takes 5 hours to produce 100 cases of cocktail glasses, the time taken to produce 1 case of cocktail glass will therefore be 5 upon 100, and that is 0.05. So we knew the time that it takes to produce 100 cases. We have just entered the time that it takes to produce 1 case. And in the case of juice glasses, it takes 6 hours to produce 100 cases. So it will take 6 upon 100 hours to produce 1 single case, and that is going to be 0.06. Likewise, in this column, I will enter the contribution to profit per case. So contribution to profit per case, and this will be in US dollars. So 1 case of cocktail glasses contributes 4.5 US dollars to our profit, and 1 case of juice glass contributes $5 of profit. So once we have entered all these, let us now enter our decision variables. So this is what we are wanting to find out: cases to be produced per week. So how many cases of cocktail glasses and juice glasses should we be producing every week? What kind of mix should we have such that we can maximize profit? So let us just assume and start with 100 cases for cocktail glasses and 100 cases for juice glasses. This is just an assumption. This is going to change once we start solving this problem, but this is a starting figure such that we can complete the rest of the sheet. So let us say we are planning to produce 100 cases of cocktail glasses per week and 100 cases of juice glasses per week. So let us start filling the other parts of this sheet. So moving forward, what will be the total space that will be needed if we are producing 100 cases of each? So let's put that here. So let's call it total space, and this will be in cubic feet. So in this particular case, we will use a formula. This is what it takes to store one case, and we are producing 100 cases. So we will enter a formula, and that will be like 100 cases multiplied by the space that is needed for each case, which is 20. So for cocktail glass cases, the total space that will be needed if we produce 100 cases per week will be 2000 cubic feet. I'm just going to drag down this formula, and the total amount of space that will be needed if we produce 100 cases of juice glasses will be 100 multiplied by 10, as a single juice glass case occupies 10 cubic feet. Let us total this up. So I'm going to come here and click on this and press on sum, and then just simply go ahead and accept. So this is the total amount of space that will be needed if we were producing 100 cases of each. Let's move forward and try to calculate the total time that is going to take to produce 100 cases of each. So let us call this total time, and this will be in hours. So as it takes 0.05 hours to produce one case, the time taken by the injection molding machine to produce 100 cases will be 5 hours, that is 100 into 0.05. Let's put this down as a formula like we did before. So this is going to be 100 cases, and the time that it takes to produce one case is 0.05 hours. So let us just put this here. So this is 5 hours. This was actually given in the problem itself, and I'm going to drag down this formula, and you will see that the time it takes to produce 100 cases of juice glasses is 100 multiplied by 0.06. So let us just total this up, sum and accept. So the total time that it takes to produce 100 cases of cocktail glasses and 100 cases of juice glasses is 11 hours. Let us now come and fill our last column, which is total profit. So let us just write this as total profit contribution, and this is going to be in US dollars. So let's put that in, and we will use a formula once again to do this. So we are producing 100 cases of each, and the contribution of profit from cocktail glass cases is 4.5 per case. So let us just use this formula and say 100 cases multiplied by 4.5, that is $450 if we are producing 100 cases per week. And let me just drag this formula down, $500, because every case of juice glass contributes $5, and we are producing 100 cases. So $500 are coming from juice glass cases. And let us total this up once again. And we are coming here and clicking on sum and accepting it. And let us just highlight this cell. So this is what we are going to maximize, and these are our decision variables. This is what we want to find out: how many of cocktail glasses and how many of juice glasses should we be producing per week such that this figure is maximized. So let us now put down our constraints also. We know from the problem story that the maximum space in the warehouse is 15,000 cubic feet. Let us write the unit here as well if we wanted to. Cubic feet. The maximum time for which the injection molding machine is available per week, that is 60 hours. And finally, the maximum juice cases that we can produce per week is 800. So these are the constraints. Maximum space that is available in the warehouse per week is 15,000 cubic feet. Maximum time for which the injection molding machine is available per week is 60 hours, and the maximum number of use cases that we can produce per week is 800. So we have our sheet all filled in, and we can now solve the problem. We want to have a production schedule, and we want to find out how many cases of cocktail glasses and how many cases of juice glasses should we be producing such that this figure, the total profit, can be maximized. So we will use the solver tool to come to an optimal solution. So before we move further and try to solve this sheet using the solver tool, I highly recommend that we give a name to every cell that will be involved in the solver solution. So let's come here and come to the name box. I had shown this in the first part, and give this a name. So let's call this cell total space. Remember that you cannot have a space in between, so I'm using an underscore and then enter. So this cell will now be called as total space. We will come here and give this cell a name. So we will call this cell total time. Let's name this cell total profit. So this cell is now called as total profit. This cell, let's call this as juice cases. Both of these cells, let's call them cases produced. Let's come to these constraint cells. Let us call this cell as max space. Let's call this cell as max time. And finally, let us call this cell as max juice cases. So we have named all these cells that we will be putting inside the solver box. I'll come to that in a second. The reason why we have named all these cells is that when we will be putting all these parameters inside the solver box, we will be able to see exactly what we are working with. So it's always a good idea to name all the cells that will be involved in the solution. So we have named all these cells, as you can see. This is maximum space, this is maximum time, and this is maximum number of use cases. We are all set to solve this problem. So to reach the solver tool, we'll have to click on the Tools tab. In Excel, the solver tool has to be added as an add-in. In LibreOffice Calc, you don't have to do anything, it's already available. It's available from the Tools tab. So it is right next to Goal Seek. This is Solver. So we are just going to come here and click on this and open a Solver box dialog. So it says, what is the target cell? So we want to maximize the contribution, the profit contribution. So we are going to come here and click on this cell. And because we named this cell, instead of the cell address like I6 or $I6, we are actually seeing the name of the cell, and this is making a lot of meaning to us rather than having cell addresses in absolute or relative terms. So the target cell will be this cell, which is the total profit contribution. This is what we want to maximize. And the second checkbox is we want to optimize the results to maximum. So we will keep this checked on because we want to maximize the profit. If you are working on a pollution problem, you might want to minimize pollution. And so there can be instances where you would like to minimize a figure. In this particular case, we want to maximize the profit. So we will leave it as it is. Optimize result to maximum. Now it says by changing which cells. So this is the third box. So these are the cells we want solver to work with, and it can keep changing these cells till it arrives at a optimal solution. So we are going to enter this here. We have to now come to the limiting conditions or constraints. So we will enter these here. In this particular case, let me just move this a little bit here so you can see everything. In this particular case, the total space that is being occupied if we produce 100 cases of each is 3000. So this should be less than or equal to, and we are going to click here, the maximum space. So this is the benefit of naming the cells, because you are now seeing the names and you can make sense out of what you are doing here. This little box here has a few options. It has greater than or equal to and so on and so forth. So we are going to use less than or equal to. What we are saying is that as you start moving these numbers, so this space, the total space, cannot exceed the maximum space, that is 15,000 cubic feet. Next, let us just come here and click on this. The total time should be less than or equal to this, which is the max time. So the maximum time for which the machine is available is 60 hours. So as you start experimenting with these numbers towards a optimal solution, this figure, which is the total time, should not exceed the max time, which is this figure. Finally, the last constraint, we are saying that this, which is the juice cases, should be less than or equal to, and we can just come here and click on this one. The maximum number of juice cases is 800. So the total number of juice cases should not exceed 800. We are doing nothing about this one because we can produce as many cases of cocktail glasses as we want. So if you look at this little dialog here, we are maximizing total profit, which is this cell here, maximizing, and this is being done by changing these two cells right here, and the constraints have been entered here. The maximum space or the total space should not exceed maximum space. The total space should be less than or equal to maximum space. The total time should be less than or equal to the maximum time, and the number of juice cases should be less than or equal to maximum juice cases. Now all we have to do is to press the solve button, but before we do that, let me just show you a few options here. You can actually choose the algorithm that solver will use to solve this particular problem, and based on your choice of the algorithm, you have a few options that you can choose right here. So we can either go with the default algorithm, or otherwise we can choose a simpler algorithm. So let us pick up this algorithm, LibreOffice Coin MP Linear Solver. You can later come back and choose another algorithm also and try to solve the problem. Let us check these also. We want the number of cases to be integers, so we don't want any decimal points because we cannot have a decimal number of cases. And we should also make sure that we are clicking on this. We are assuming that variables are non-negative, so we don't want the number of cases that we will be producing every week to be negative. So we can just check this two options on. We are using the LibreOffice Coin MP Linear Solver. This is the algorithm that we will be using. You can come back and try the other algorithms also. I'm just going to go ahead and press OK. So all that needs to be done now is to press the solve button. So when I do this, you will immediately see the solution, and the result is 5142. And if we can just keep this result, you will see that this is the maximum profit, and to achieve this profit we will have to produce 426 cases of cocktail glasses and 645 cases of juice glasses. Remember, the constraint here was that these cases should not exceed 800. The space should not exceed 15,000. So this is completely met, and the total number of hours for which the machine was available should not exceed 60. So with this combination, this condition is also being met. So all the three constraints have been met. The juice glasses do not exceed 800. The total space that is occupied does not exceed 15,000 and the total number of working hours per week does not exceed 60. And if we are producing 426 cases of cocktail glasses and 645 cases of juice glasses, we will be achieving the maximum or the most optimal solution. Every week we will be able to get $5,142 in terms of profit. So this is the power of solver. You can solve a number of such kind of problems with multiple variables, linear programming problems using solver. So if we go back again to tools and click on solver, you will find that whatever you have entered is still visible, and you can go and change the algorithm or try something else and press the solve button. If you wanted to add a few parameters, you can add those few parameters. If you want to delete a few parameters, you can delete a few parameters. But then this is how our solver works. It's pretty simple to do once you set up the sheet properly and put in all your constraints. And this is not the only way to enter data. You can enter data in another way also if you prefer that. But as long as all your numbers are on the sheet, you can come to tools and click on solver and then put in what you want to maximize, which cells you want solver to play with. Recall that we started with 100, and solver has ended up creating an optimal solution with 426 cases of cocktail glasses and 645 cases of juice glasses. So these were the cells that we had mentioned here, these two cells. And then this was followed by entering your constraints here and then just simply going ahead and pressing solve. So this is how you can use solver to solve linear programming problems. I hope this video was useful and it can help you use solver to solve multiple variable optimization problems. I look forward to seeing you in the next video. Thanks a lot for watching.